Okay, now we will continue with our second topic, that is models with qualitative X, or the qualitative explanatory variables. Sometimes it is called dummy variables. Actually, again, we've learned this in class, but for this session, I just want to give you like a detailed explanation on how to do modeling with the qualitative explanatory variables, and then how to do the data processing in R, and then how to do the inference or do the interpretation of the result. Okay, again here we will be referring to Mendenhall book on page 228. Actually, it's not 228. The page number is on page 213. Okay, so modeling with qualitative. So as we learned before, the scale of the variables, there are two main scales of the variables that they are qualitative, or generally known as categorical variables. And the other one is the quantitative, or we usually know it as the numerical variables. And for the qualitative variables that we will consider here is on the first level, that is the nominal scale. We know that there are two types of qualitative variables. They are nominal scale and ordinal scale. We will just be considering the nominal scale here. Okay, so now let's just, because we have the theory in our lecture before, so then how do we incorporate the qualitative variable? Is that by creating a dummy variable? Dummy is that you put like a binary variable as an indicator of the level. So for example, if you have two levels in your categorical variable, then you need only one dummy variable. If you have a categorical variable with three levels, then you need two dummy variables. How to do it? Let's just proceed directly to the example to make it clearer. So here that we have an example of data in table 4.4, that is for example 4.5 in Mendenhall book. So in this data, we want to model the shipment cost. So the response variable Y is the shipment cost based on the regional express delivery service. We want to model the shipment cost Y of a regional express delivery service, and then we want to know whether different cargo type will, I think of course, will result in different costs, but then how much is the difference? That's what we want to know here. So then in here, we are given that, okay, so for the first package, the cost is $17.20 with the cargo type of fragile, and then for example like the 12th package, the cargo type is durable, and then the cost is $1.3. So in here we have one explanatory variable, that is cargo type, but with the three levels. The levels are fragile, semi-fragile, and durable. So if we want to model this according to our theory, then we can just write it down as, okay, I'll just make this a bit bigger. Yeah, okay. So then we just go down here. We just delete this from the previous. Okay, just delete that one. Okay, so our model would be, I will just say cost. Okay, so cost equals to, or what is it called? Cost equals to beta naught plus beta 1. Some people might write it as like this, okay, and then plus the epsilon. where your epsilon follows normal distribution, independent and identically distributed, with the mean of 0 and the variance of sigma squared, and the value of sigma squared we can just estimate it given the data. Okay, if you write it like this, what's the danger in doing this? Okay, so I think that I need you to, this is the first question that you need to answer. You can just write down the answer and send it to my email, or you can just type your answer in the comment below. Okay, so then we will not be considering this model. Okay, and then okay, I'll just show you what is it, some mistakes that people might do in modeling this kind of data. Okay, so then people might argue that of course you can't do this because the cargo type is that, the value is fragile, semi-fragile, and durable. So I'll do something else. For example, that I will define my variable as, okay, I will have, I will have this model again, but then with, I'll just change it into x, okay, my independent variable, with x equals 1 if cargo type is fragile, and then okay, x equals 1, 2, 3 if cargo type 1 if it is fragile, 2 if it is semi-fragile, and 3 if it is durable, respectively. Okay, so now here it is string word. You can't do calculation with something that is not numbers. In here, we change the cargo type with a value of 1 to 3, where 1 represents fragile, 2 semi-fragile, and 3 durable. So then we can do the data processing. Yes, you can do it, but there's still, it is still, not okay. There's still a mistake in doing that. And I want you to tell me what is the mistake in doing the modeling like this, number 2. Okay, and then so the third way of doing it is that I'll do it like here, x1 plus beta 2 x2, okay, where my x1 and x2 is defined as, x1 equals 1 for fragile, and then 0 for others. If cargo type is fragile, and 0 otherwise, and then I just copy this, x2 equals 1 if cargo type is semi-fragile and 0 otherwise. What about durable? Then durable can be, we don't need to define additional dummy variable for durable, because if x1 equals 0 and x2 equals 0 altogether, it means that the cargo type is not fragile and not semi-fragile either. So it means that the remaining category, which is durable. So that's why we don't need another dummy variables. Okay, so then this is what model number 3 is the one that you should do. Although in here, for example, okay, what if I want that x1 to be 1 if cargo type is durable and x2 is 1 if cargo type is fragile? The answer is yes, you can do that. But then, again, there should be like some differences in the results between your model and then my model here. And again, so this is the third question for you to do. If you, okay, I'll ask you, I'll be explaining and running this model, okay, and then you will do this, okay, if durable, and then I just change this, okay, and then for your third task, you will do this, okay. So now, let us see, how do we proceed and what can we tell about the phenomenon or the condition represented by this data. Let's just go on data processing. In here, I'll just do a different way of imputing the data, while in the previous lecture for quadratic regression, I did input the data straight away in the R program, but you know that is kind of like, the problem with this one is that if there's like one or more than one data points that you missed, it's kind of like, okay, quite difficult to check which one is missed. And then, yeah, especially when we have kind of many data. So I don't really recommend you doing data, input your data with this kind of process. You can do this, for example, just for a small size of data like 10, 5 points is easier. But then if your data is getting bigger, more complicated, I recommend you to input it in Excel. Okay, so then to save time, I already input the data here. So, okay, let's just delete this one first. Okay, so basically, the data that represented in table 4.4 is about the cost, that is the y or the response variable, and the cargo type, that is your x. But then, according to our concept of how to treat the categorical variable properly, we need to create two dummy variables for this one. That is namely x1 and x2. And x1 equals 1 if it is fragile. Okay, so I just put equals if this is fragile. How do we call it? Okay, so this is, if this is let's see, fragile, then the value is 1, otherwise it is 0. Okay, and here I'll just copy this formula, and then if the value is semi-fragile, then the value is 1, otherwise the value is 0. So we can see here the first one fragile, then x1 equals 1, x2 equals 0, and then you just, okay, so here for example, the 11th package that costs $2.1, it is not fragile, it is not semi-fragile. So what is it? It's of durable type. In this case, we call that the durable is the base level. So in here, I will say that the base level is durable type. Okay. So then we have this one, just save it, and then I'll do import from R. And then based on my experience, it's better to save it in the form of text file. So then, okay, I already saved it in the in the form of text file. Using Excel is sometimes complicated in my R. I don't know why. Okay, so here then we proceed to this one, and then to import the data, you need to call the library get data. Okay, if you run this and then you get an error message, it means that you need to install the package. You can go here and then you just find it here, find the G data. Okay, where's the G data? G data means get data. Oopsie, there's so many packages in here. Unfortunately, we can't just type and then it gets there straight away. You have to just scroll until you get the one that you need. And then you click OK. But because I've already downloaded, so I don't need to install it. I just need to, every time you need it, you just need to call the library. Okay. And then, because I'm trying to do data import, then I need to set the working directory. So the working directory is that directory that you want to save or you want to get your data. So then, because, okay, I put my data in here. Where is it? This one. Okay. Just delete this one. I'm not using this. Okay. So here is the working directory. Instead of typing it, I just need to copy the address and then you put it here. Okay, I'll just redo it for you. Yep. It's like that. If you try to run it, you get an error message. It turns out that it needs two of these symbol. Yep. And then try to run it again. Now you are all set. Okay, and then try to call your data. Let's say I put the name as data 4.4 just to remind me that's from table 4.4 of the Mendenhall and Sinchich book. And then read table, and then here is the file name. Sometimes I'm not really good at memorizing, even there's just a simple file number, a file name. So I just go here and then do this and then copy the file name, and then we just put it here and put the extension text. Okay, if you don't put this one and then you see the result, it's like that, because it says that this is one of course cargo type is one of the observation, and it will give you the number, the file name, the variable name automatically as V1, V2, V3, and V4. And we don't want that because course cargo type, they are our variable names. So we need to put that header equals true. And then let's see. Oh, okay. I was wrong. Oopsie. It should be, yep, and here. Okay. And then if you want to see portion of the data, it's like that. So they are all good. Head is just giving you like the first six of the data. If you want to see the whole data itself, you need to do a few data, and here's what we got. Okay, we have 15 observations for variables where x1 and x2 are just dummy variables representing the cargo type. Okay, just like before, dim gives us the dimension of the data. The first dimension is 15, which means that that there are 15 observations here. 4 is 4 columns. And then what are those columns? Then you can just type the names. This is just to show you how to do it. Okay, actually you don't need to do that. So these 4 columns are called cargo type X1 and X2. Okay, but then just delete this one. Now what are we going to do with this one? We want to do the regression. And then what is the regression model? Like before, it is of this kind. Okay, oh no, this one. This is the number 4. I'll be doing number 3. Number 4 is for you to do, okay? So then, how do we do that? Okay, I will just say fit 1 because I want to show you several ways of doing it. Fit 1 is the linear model where the response is the cost, and then the categorical explanatory variables are x1 and x2. Now, if you do this, it will say that object cost not found or cannot identify what object is it. So you have to say that cost in the data named data 4.4 and then you put the dollar. Okay, and then the same for other variables. So just to identify, take it from this data set like that, and then you get the result. But this is kind of messy, right? I don't really like it, so there's another way of doing it. So we can just, I just copy this, and I just comment this out, this is so messy, so I don't like that one. I'll just keep writing cost as a function of x1 and x2. But then we say that get it from data. The data is data 4.4. And then you can proceed with that one. So then another way of doing it, no, it's alright. We will just proceed with this one first, okay? And then so let's see the result. Summary of fit 1. Okay, here we go. Seems good. But then you know what? Actually, you don't really need to do this. You don't really need to create x1 and x2. You just by just impute cost and cargo type is enough in R, because how do we do that? It's kind of like, let's say second version. I just do fit 2 is cost as a function of, what was the name of it again? Cost as a function of cargo type, and data is data 4.4. It works. Yep. So because you have that cargo type here, where is it? Here the cargo type is that class of cargo type. It's data 4.4 dollar cargo type factor, because it's in the form of string, so R automatically detects it as factor or categorical variable. And then from this result, where is it? Here it automatically record your x1 is fragile, x2 is semi-fragile. I think that how the way it records is, it will just take the first category or the first level to be the first variable, the second level to be the second variable. Okay, you can try, for example, just like, you change this, you put it here, and then let's see what. Okay, sorry. Yeah, I mean that you can do it later. Yeah, okay, you put durable, and so up here, so I think that it will come out that durable will be the first dummy variable, and semi-fragile will be the second dummy variable. Okay, now let's have a look at the result. Okay, um another way to say, okay, I just want to show you another one. Okay, like for example this one. Okay, showing what we did in model number 2 here. Okay, so fragile, we put 1 for fragile, and then 2 for semi-fragile, and then 3 for durable. Okay, we did that, right? Then just save this again as yep. Okay, and then again just import this one, and then just this is for another purpose. Okay, we have one more column here. Okay, so let's just proceed with this one first. This is the suitable one to do, right? Okay, we get this result. So how are we going to interpret the result? Okay, we see actually globally the model are good. Okay, the p-value is so small, and then from here the partiality test, we can see that each of the type is significant, with the p-value is less than our alpha of 0.5. So then how do we do the interpretation? Then we should just write, okay, so the model fit is given by, okay, so the head of the cost, which means that the predicted cost is given by 3.26 plus 9.74 if your cargo type is fragile. So I will just write it as fragile. No. Okay, but in here I already write it as x1. Okay, so x1 plus 5.44 of x2. Okay, that's the model fit. And then how we do the interpretation, actually it's quite simple, but then I just write it down, the mathematical what is it process of doing it. Let's say that now if the cargo type is fragile, then this one is just copy. Okay, then the model fit becomes fragile, then x1 is 1, right? And then x2 0, because it's fragile, so it's not semi-fragile, so this part is gone. Okay, while if it is semi-fragile, what we have here is that, okay, semi-fragile, so x1 should be 0 because it's not fragile. This one is gone. Semi-fragile, so x2 is 1. Okay, and then what about the durable type? The durable type, we have that x1 is 0 for durable, x2 is 0 for durable. Okay, so actually those are the one that we have. Okay, I just put it like this so it's easy to compare. So what does 3.26 minutes. As you can see here, it's like the expected cost of shipping when the cargo type is durable. And what does 9.74 means? Here, 9.4, when it is fragile, the cost is this one, which is the cost for the base level that is durable, plus this one. Okay, so 9.74 is the difference between the fragile and durable type. So we can say that 9.74 is that the excess cost of the shipping when the cargo type is fragile compared to if it is of durable type. And the same thing here, 5.44. So if the cargo type is semi-fragile, then it costs $5.44 more expensive than if it is durable. So this kind of, we can say that these regression coefficients, they represent the difference in the cost between this type with the base level. In our case is the durable. Okay. So what if, for example, you want to compare the fragile and semi-fragile? Yeah, you can't do it in here, but you know, it's just a simple math, right? Semi-fragile and fragile. Fragile, you just take the difference between 9.74 and 5.44. So we know here that fragile is the most expensive one, and semi-fragile is the second most expensive, and durable type is the least expensive type of cargo. Okay. Okay, and here we have the R squared is 77%. So 77, around 77.5% of the variability in the cost value can be explained by the cargo type using this model. But then, of course, I mean that you might think that 77.5 is kind of like low compared to like the previous examples in the quadratic regression, but it just makes sense. I mean that when you are doing sending a package, it's not only the type. I think like the weight of the package, the size of the package could also should be included in the model. They are much more explaining probably. So then what we can take from here is that a low R squared doesn't mean that your explanatory variable is not working properly. It might probably due to we need to add some more explanatory variables. So in here, this is good enough. It's just, you know, ridiculous to predict the cost by just knowing the cargo type. You should have more information. I think like I said before, the price, not the price, I mean that the weight, the size, the type of objects that you send, that kind of things. Okay. So that's for the categorical variable. Remember before, so you need to do your own if you change the baseline, and then see the questions that you need to answer is that will the estimates change? I think yes. And then can you guess it without running the data? Okay, can you guess what is the estimated value for beta 1 here? The beta 1 here. What is the estimated value for the beta 2 here? I think that actually you can do that, and then you show me the process, okay, of getting the estimated value of beta 1 and beta 2 without running the data processing in R, but also in addition to that, you also need to run it in R. So to confirm that what you've done mathematically is in line with the data processing. Okay, now I just want to add one more thing for the categorical model. Okay, before this one, okay, let's say we do something like this. That's why before, okay, I add one more variable, that is x. X is 1 for fragile, 2 for semi-fragile, and 3 for durable. Okay, so let's see third version. What happens if we do that? Okay, I just change it to fit3. So this is not cargo type, but X. Data is like that. If we run it, yep, it's okay. And try to get the result. Yep, you are given the result. So again, this is our next task. So I will just write it here. La 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 la. Here. Okay. This is our next option. It should be the fifth one, right? Oh, I don't know. Oopsie daisy. Oopsie. Yeah. Okay. So this model, we try to run this model, we get this result. So can you please just give me the interpretation and whether you think that whether the interpretation makes sense or not. Okay. And then, okay, if we can run something like this, then what if, okay, we try another way of record the data like X star. I just put it as X star. And then for fragile, I just, because one is for fragile, so I just put, I don't like fragile, I want the durable to be 1. And then I don't like even numbers, for example, so then I want fragile, this one to be 3. And then here I like it to be 7. Is it okay? Remember that this is just, the coding, just an indicator of a different level of categorical variables. So then you're free to do your, data record your data. Okay, so I can do something like this and then just save it and then call it again, because now I've added, where do we call it? Okay, now we have that X star, right? And then try to run it again, the fourth fish version. This is not X but X star instead. Okay, and then we get this result. Okay, compare it with the result of fit 3. Okay, I'll just show it here. Okay, this is from the first fit 3, this is fit 2, right? 3 and 4. Oh, okay, I need fit 3 and fit 4. Okay, fit 3 and summary of fit 4. Okay, so fit 3 is by using this kind of recode. Fit 4 is using X star, and then we get this result. Again, computer is just, just doing the calculation. You put in something that they need, it needs a number, you put in number, it will give you the result. And it seems like, wow, that's really good. You have it's very significant, right? And then what else here? You have the R squared is 72.4%. It's quite good, not really different with the one that we've obtained before from here. From fit 2, here is 74%. Okay, going back to this one, I just too lazy to scroll it up. Okay, so here we see, that's really good, significant. P-value is very very low. R squared is nice. So this model is good, but there's a big mistake in it, and I want you to tell me what the mistake is. Okay, and then also the same with this one. Here, wow, it is really good. Okay, the result is really significant, and then the R squared, wow, it's 77%. It's just similar like the one that we've done here in the suitable, the appropriate one. So seems like, wow, this is really good, and it's much more simpler, right? You have just one variable compared to this one. That the cargo type here we have like two dummy variables, and R squared is just 77%, the same just like what we do in here for the cargo type with two dummy variables, and it's significant. Oh, everything looks so good, but again I want you to tell me what is wrong with this, with doing something like this. Okay, so then what you can do is just something like of the second version. You can just change the recording, change the base level. Of course, the beta will change, but then in the end, the interpretation will be the same. And I want you to tell me again, based on here, you run this, you get something, you do your interpretation, and then see if the result is the same as the one that I've done here. Okay, is it clear? I think there are so many tasks that you have to do as a result of this lecture. The first one is that actually we've answered this one, we can't do this. The second one here, there's like, okay, we tried to run it with two different codings, record of X. So that is by trying X and X star here, and then we already ran it using the third and the fourth version, and then I want you to tell me what's wrong with that one. Okay, and then another one is here, try for this kind of decode, or you can just change it, but should be different from the one that I've done. So you can just have x1 is for fragile, x2 is for durable, so your base level is the semi-fragile, whatever you'd like to, as long as it's different from here. And then there are two things you need to do from here. You need to guess, not really guess actually, you need to find the value of beta naught, the estimated value of beta naught, beta 1 and beta 2 without running it. So you need to show me the mathematical procedure of getting beta naught, beta 1 and beta 2. Again, without running or without calculating from the data, just based on the result that I've got here from this one. Okay, so you can just, the clue is that you can get information on the value of beta naught, beta 1 and so on from this result. Okay, and then just show me the mathematical form, and then you also need to do the same thing like the one I've done here, and then so that you can confirm the ones that you derived or calculated is the right one, the correct one. Okay, so I hope that by this session you know how to treat the categorical variables, and then you are aware of the danger in mistreating the categorical variables. Okay, thank you. See you in another session.